The last bit of our application of exponential and log lessons takes us through some scales that you might be familiar with. They include the Richter scale for earthquakes. They include a discussion about sound using the decibel scale, as well as the pH scale. So today we're just going to try to get into the meat and potatoes of this lesson. Remember, we're testing and quizzing on this material after teacher's convention. All the scales of today are logarithmic. A difference in 1 unit on the Richter scale corresponds to a factor of 10 difference in the intensity of earthquakes. That means that each whole number step represents a 10-fold increase in intensity. A magnitude 9 earthquake is actually 10 times larger than an 8, 100 times larger than a 7, and 1,000 times larger than a 6. So we get to play with some of the earthquakes that you may have heard about historically and describe how their intensities are related. So an earthquake of magnitude 8 is 10 times more intense than an earthquake of magnitude 7. We're looking at subtracting the exponents and attaching that to a base of 10. So when I go from 7 to 3, I'm going to go 7 minus 3, so 10 to the 7 minus 3. That's 10 to the 4 times as intense. When I go from 4 to 6, I'm actually going up. And how is that going to be rated? Sorry, we're actually comparing backwards. I'm comparing a 4 to a 6. A 4 is less intense, and we're going to do that same type of subtraction. Take the exponents and subtract them. So that's 10 to the minus 2 times. You can change that into a number. An earthquake of 4.8 is how many more times intense? We get to do that same subtracting. 10 to the 4.8 minus 6.8. That's still a 10 to the minus 2 times. And now we get a look at the earthquakes in Chile, Colombia, and Italy. So in the 1960 earthquake in Chile was a 9.5. And then I went to Italy, which is a 6.5. And then I went to Colombia, which is a 5.5. So hopefully those numbers stay for me. So in going from Chile to Italy, I'm going 9.5 to 6.5. The earthquake in Chile was 10 to the 3 times as intense. 10 to the 9.5 minus 6.5. That's 10 to the 3 times as intense. If I go to the one in Colombia, I'm going 10 to the 9.5 minus 5.5. That's 10 to the 4 times as intense. So earthquake intensity is something that you might have heard a little bit about. Edmonton isn't that well known for earthquakes, but the earthquake intensity, it actually has a formula that we should take a look at. So the magnitude of an earthquake, as listed on the Richter scale, is defined as a ratio between the log of the intensity of the earthquake as experienced and the log divided by a base intensity. And we're comparing earthquakes all the time. We actually want to see why we can do that subtracting in the way we've been operating. So let's check that out. I'm going to sub in for M1 and M2 and then see if I can make that statement equal. Now that we have some familiarity with logs, I can take the substitution for the magnitude of the first earthquake, subtract the magnitude of the second earthquake, use my log rules to combine the two logs into a single log, simplify those logs. A fraction divide by a fraction, multiply by the reciprocal. I get a nice log statement. The log of the intensity of the first earthquake divided by the log of the intensity of the second earthquake is equal to the difference in their magnitudes. And if I want to know the comparison of intensities, I can convert to exponential form, and I've got this nice little equation that we've already been running for earthquakes. So hopefully that makes sense. Here's the intensity descriptor, and we've been doing some work with that already. Looking at looking at an example for an earthquake where the magnitude is described as being 375 times as intense as a minor earthquake. So I can take the ratio between their magnitudes, 10 to the 7.5 minus x will be a descriptor of the ratio of their intensities. I know that it's 375 times as intense. So the I1 and I2 I've replaced with 375. And now I'm looking at solving for x. X is in a exponent position, so I need to take logs of both sides and solve for x. So that's the log of 10 to the 7.5 divide by 375 being equal to log base 10 of 10 to the x. So the x moves down into the exponent position or into coefficient position, and I'm going to get x by doing the work of the left hand. So x is equal to 4.9. Remember, log base 10 of 10 is 1. Let's turn the page over. Loudness of sound was described by Alexander Graham Bell, named after him. The unit is the decibel, which is a metric prefix. Deci means 10 to the minus 1. And when we look at a difference in the decibel scale, if there's a difference of a leaf rustling, 10 decibels or 1 bell is 10 times as loud as the threshold of hearing. So the leaf rustling is 10. The intensity is a factor of 10. And we've got the same kind of subtraction happening here. So let's try that out. So we actually have to convert to our bell scale. So I have to take all my decibel values and divide by 10. We'll take a look at the mathematical descriptor on the next page. So I've taken all of my decibel readings and divided by 10. And then I'm finding the difference like we did before. So the power saw is 10 to the 4 times as loud as a dial tone. A jet engine is 10 to the 2 times as loud as the threshold of pain for my hearing. And a whisper is 10 to the minus 3 times as loud as a conversation. That means it's quieter. So here we have the formulas for decibels and for bells. So there's where we needed to be dividing by 10 when we were working for decibels. The formulas look very similar to our work for earthquake intensity from before. We're just going to do 1 decibel question on phones that ring. Are they really twice as loud? Had some trouble with my sound. I hope this is better again. We want to try to figure out what the intensity is like for those 2 phones. So I've got 2 phones ringing at 8 bells compared to 1 phone ringing at 8 bells, and I want to solve for x. So I have 2 times 10 to the 8 being equal to 10 to the x. I'm trying to figure out the decibel rating. Take the log of both sides, a very familiar skill. The log of 2 times 10 to the 8 is actually 8.3. That would have been the unit bell. Multiply by 10 to get decibels. Now we're going to talk about pH. So if you survived Chemistry 20, you know a lot about the pH scale. Our textbook last year used lots of really nice numbers, and a pH jump of 1 actually corresponds to a hydrogen ion concentration that changes by a factor of 10. The negative is there because the numbers for concentration are between 0 and 1. So we'll do some comparing of the pH chart down below. When we work with the pH scale, we actually have to recognize that there's a negative in there. So we have to take the negatives into account, which is why I subtracted the second from the first from the second, trying to understand that difference needs to be communicated. So envision your negatives, if you're not in chemistry, envision your negatives actually on the pH scale. So when I look at eggs that are at 8 and pure water, which is at 7, I'm going to go 7 minus 8, which is 10 to the 1. Please notice that the labeling becomes acidic and alkaline. So when we're dealing with the acidic differences, we want to take the bigger number and subtract the smaller number. When we're looking at alkaline differences, we actually want to do the same thing. So that first one should have been 10 to the 8 minus 10 to the 7, or 10 to the exponent 8 minus 7, to understand that eggs are 10 times as basic as water. That's what alkaline is meaning. So when I'm looking at milk of magnesia being a reference to blood, blood and milk of magnesia are both alkaline. So we're looking at that alkaline measurement. And we're going to generate a positive number for the alkalinity. So I'm going to go 10.5 minus 7.5 to get the alkalinity increase. So that's 10 to the 3 times. So our last example has us actually dealing with solving a logarithm statement. They finally told us what pH is defined as, and I'm going to, for the hydrogen ion concentration, by going a second log. That's one way of writing it from our chemistry perspective, or converting it to exponential form. Move the negative over. The exponent negative 5.7 will be equal to my hydrogen ion concentration. So sorry for the problems with the sound on this lesson and a little bit of orientation. We're going to take a look at one more thing today in anticipation of Teachers Convention, allowing you to complete all of our 4th unit and start our 5th unit. So thank you very much.